Hello everyone and welcome back. I'm Mr. Cobalt and today I'm going to be talking about solubility and solubility rules for ionic compounds. Now here is the solubility rules or solubility chart, and I want to go over how to read this chart. So you'll see that it's divided into two parts. From the left side and the right side, and it's also divided into two parts, top and bottom. And so here are, on this side, on the left side, are going to be the examples of um, ionic compounds that have these ions in them, whether they're soluble or not. And on this side are going to be the exceptions to that. So here is the rule regarding whether or not the ions or the ionic substances containing these ions are soluble. So generally, the ones in this side of the table here, on this top part of the table, this has to do with whether or not they are generally soluble, right? And then this part below has to do with whether they're generally insoluble. So you got to pay attention to the wording. So everything here that falls below here has to do with whether or not they are soluble. So any ionic compounds that have these ions in them are generally soluble. And then on this side, there's going to be some exceptions or not. So, for example, any ionic compounds that have lithium, sodium, potassium, or ammonium in them are going to be soluble. And there are no exceptions to this. So if you see a compound and you want to know if it's soluble or not, and it has any four of these, then you know it has to be soluble because there's no exceptions to it. So lithium, sodium, potassium, and ammonium. Any compounds that have those are going to be soluble in water. Same thing for nitrates and acetates. So this is acetate, this is nitrate. So any ionic compounds that have nitrate or acetate in them are going to be soluble in water. And again, there's no exceptions to this. So if you find a compound that has either nitrate or acetate in it, then you know it has to be soluble in water. Same thing goes with chloride, bromide, and iodide ions. So generally, those are going to be soluble in water. Any compounds that have these are going to be soluble in water. Now, there are exceptions. So if you have an ionic compound that has silver or mercury 1 or lead 2, if you pair these up with any of these three, then that compound is not going to be soluble. Other than that, if you have chloride, bromide, or iodide in your ionic compound, those will be soluble. But watch out for the exceptions: silver, mercury 1, and lead 2 ions. All right, so that takes care of the generally soluble ions and their compounds. What about the compounds that contain the following that are insoluble? So from below here, these are going to deal with compounds that have these are going to be generally insoluble now. So for example, if you have a compound that has hydroxide ion in it or a sulfide ion in it, generally those are going to be insoluble in water. And there are exceptions. And it's funny that you notice the exceptions, because what do you notice about the exceptions to these, right? Lithium, sodium, potassium, and ammonia. Where did we see those before? Right here, right? Remember, there's no exceptions. So if you have any of these ions in your compound, then those are going to be soluble. No exceptions. So if you have these two ions, right, those are going to be insoluble unless they are paired up with these four. Then they got to be soluble. Okay. Sulfide ion, if it pairs with calcium, strontium, or barium, that's going to be insoluble. Okay, so these three, if you have these three ions paired up with sulfide ion, then it's going to be soluble, right? Otherwise, it's going to be insoluble. For hydroxide, same thing. Hydroxide, if it's paired up with calcium, strontium, and barium, it's going to be slightly soluble. So not insoluble, but slightly soluble. Okay, so, and those are the exceptions. And then finally you have carbonate and phosphate. So again, we're talking about under this category of insolubility, compounds that have carbonates and phosphates in them are generally insoluble. However, again, if you pair them up with lithium, sodium, potassium, and ammonium, again, these four here, if you pair those up, then they are soluble. Otherwise, they are insoluble. So that's how you're going to read the solubility rules. So if you are trying to figure out if you have a product that's insoluble or soluble in water, or if there is a certain compound that's soluble in insoluble water, if it's an ionic compound, you can use this solubility chart to figure out whether or not it's going to be soluble or insoluble. So this is going to be very helpful for, especially when you balance those equations or you do a precipitate reaction where you have to predict the products, and then you have to look at your products and say, okay, do I have any of my products, are they insoluble in water? If they are insoluble in water, that's going to be a precipitate. So this is going to be invaluable for figuring that out. I hope this was helpful, and if you liked this video, please like it, share it with your friends, subscribe to the channel, and make a comment in the comment section so that way you can make a comment, tell me what you think, and ring the notification bell so you can get notified when I put out a new video. Thanks for joining me, and I'll see you next time.